Hello ladies and gentlemen, today we're going to cover the first two sections of Chapter 14. Chapter 14 is on algebraic fractions. Adding fractions, subtracting them, multiplying and dividing. There's a lot of factoring in this. We're going to solve equations that have fractions in it. It's all about fractions. So, to get started, today's lesson is going to deal really primarily with reducing fractions to the lowest term. A fraction is a division problem. It is just a way to express division. X over 2 in this first example here is x divided by 2. 2 over x is 2 divided by x. 4c divided by 3d is 4c over 3d when we write it as a fraction. These are division problems, and we cannot divide by 0 ever in algebra. If you could try it on the calculator, you're going to get an error. Alright, undefined fraction. So this fraction is called undefined if there is a 0 in the bottom. So there's a whole host of questions on the Regents exam where they are going to ask you to figure out what makes a fraction undefined. When you're asked what makes a fraction undefined, you're going to change the directions. What makes 0 appear in the denominator? The easiest way to figure that out is actually take the denominator of the problem, set it equal to 0, and solve it. Okay? So if I solve that, I get x equals 5. That means that when x equals 5, x plus 2 over x minus 5 is undefined. It's a really fast and very easy way that you can determine what value will make a fraction undefined. So in problem 2, 6x is the denominator. I'm going to set that equal to 0. I'll divide by 6, so x is equal to 0. That will make it undefined. And notice in example 1 here, x plus 2 is on top. I don't care about that. I don't care about that. Unless I can factor it, I'm not going to worry about it. Problem 3. 10 over 2x minus 1. I'm going to take 2x minus 1. I'm going to set that equal to 0 because this will be undefined when x is equal to 1/2. So I take 2x minus 1, I set it equal to 0 because I'm trying to figure out when it's equal to 0. Add 1 and divide and get x equals 1/2. Okay, so here's what I want you to do. Pause the video for a second. We have all 6 of these problems up here. And I want you to try to figure out what values will make each fraction undefined. What values will make 0 in the denominator. Alright, go ahead and do that now. I'll sing you a little song. La di da 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 do 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 do. Pause the video and try these problems. Blah 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 blah. Okay, we're back. Alright, here are the answers to these problems very quickly. X equals 0 is going to make number 1 undefined. X equals 5 makes number 2 undefined. Let's see, 2 minus x equals 0. If I add x to both sides, I get 2 equals x. So x equals 2 makes number 4. Apologize about the numbering problem. Makes 4 undefined. Okay, y plus 2 is 0. So when y is negative 2, number 5 is undefined. We saw this example up above. When x is 1/2, number 6 is undefined. And 7, this one's interesting. I have difference of 2 squares. So I got to factor the bottom. It's a quadratic. There are 2 solutions here. I want to know when that's equal to 0. Oh, look at that t-chart. I know you love the t-chart. Don't pretend. Don't pretend. I bet you drew a t-chart up on your wall the first time you ever saw one. And you look at it when you're studying. It inspires you. When x is equal to 2 and x is equal to negative 2, that's going to make 1 over x squared minus 4 undefined. Quadratic equations have 2 solutions. When there's a quadratic equation in the denominator, there's going to be 2 different values that make the equation undefined. Alright, moving on. A fraction is in lowest terms, reduced, when its numerator and denominator have no common factor other than 1 or negative 1. So we are going to reduce the fraction here. Alright, so in trying to reduce this, the big question we're trying to figure out is what goes into 5 and also goes into 10. We can actually rewrite the problem if it helps. Can you tell I'm walking back from my desk right now? 5 over 10 is 5 times 1 over 5 times 2, and boom, the 5's cancel. This is 1/2. You can do the same thing down here. Now I'm going to rewrite the problem. This is 1a over 2a. That's 1 times a over 2 times a. The a's cancel out. It's 1/2. If you have the same term on the top and bottom, you can cancel it out. 4 times x over 5 times x. The x's cancel. So this is 4/5. Now, this is a little bit more complicated, isn't it? 15x squared over 35x to the 4th. How about, let's see, 5 times 3 times x squared over 5 times 7 times x squared with an x squared left over. 5 times 3 times x squared is 15x squared. 5 times 7 times x squared is 35x to the 4th. Boom, boom. You're left with 3 over 7x squared. Okay. Another way of doing this, 5 goes into 15 3 times. 5 goes into 35 7 times. I'm going to take 2 x's out of the top, which leaves 2 x's on the bottom. So you have 3 on top, you have a 7 and an x squared on the bottom. A little messier doing it that way, but it also works. Alright, here's the heart of the matter. So we've done that before. That's not new material. But take a look at problem 5. 2x plus 10 and 3x plus 15. 2x plus 10 is a binomial. You can factor it. It has a greatest common factor of 2. If you take 2 out of 2x plus 10, you're left with 2 times x plus 5. If you take 3 out of 3x plus 15, you're left with 3 times x plus 5. Now, because x plus 5 appears on the top and the bottom, you can cancel it out. So x plus 5 goes, x plus 5 goes, and you're left with 2/3. Alright, let's take a look at these examples. All of these examples require you to factor first. And these problems will vary in level of difficulty because it's based on whether or not you personally can factor. So if you can factor the problem, you're going to be great, and if you have trouble with it, it's going to hold you back. Question 8 has a special case that we need to talk about. Alright, first things first. Number 7. We have x minus 4 times x minus 4. That's what squaring means, multiplying it by itself. For the trinomial, we have to do the puzzle. So factors of 4 that add to be -5 are -4 and -1. So x squared minus 4x minus 1x plus 4. I take an x out of both of those. I take a -1 out of both of those. This is x minus 1 times x minus 4. Now look at. Alright, so that's what we have. You cannot cancel something out of the top and bottom that has a minus sign or a plus sign with it unless you can get rid of the whole thing. The x minus 4s, I'm going to get rid of the entire x minus 4, gone. But I can't break up x from the x minus 4 over the x minus 1. I have to leave this because x isn't by itself. It has the minus 4 after it. On the bottom, x isn't by itself. It has the minus 1 after it. So I can't break those up. This is really important, and it's what holds people up in this chapter. X minus 4 is a term. You can't break it up. You can only break up parts of multiplication. On top, x minus 4 was being multiplied by x minus 4. I could get rid of one of them because they were exactly the same on the top and bottom. I can't pick them apart piece by piece like that. Alright, 8. Well, first things, I'm going to leave the numerator alone. Can't really do anything with that. On the bottom, however, I can take a GCF out. 4 goes into 8 2 times. I'm left with, and I'm just rewriting this because it's kind of sloppy. Now this is a trick. If you want to get 100 on the chapter test, you're going to memorize this trick. I have a 2 minus x on top and an x minus 2 on the bottom. Same numbers, but the signs are messed up. I can cancel these out, but I have to put a -1 in its place. The -1 allows me to deal with the fact that the signs are screwed up. And this is -1 over 4. Alright? So anytime I have something like that, I have 3 minus y, y minus 3, that's -1. Same numbers, same variables, but the signs are screwed up. On top, 3 is positive, y is negative. On the bottom, y is positive and 3 is negative. I can cancel them, but I have to put negative 1 in its place. All right, number 9. I factor the GCF out of the top. 3 times x plus 6. I have an 18 on the bottom. I can cancel 3 and 18. How many times 3 going to 18? 6 times. That's x plus 6 over 6. Trying to tease you, getting you to cancel those 6's out, but you can't do it. X plus 6, they're locked together and can't be broken apart. Now, if I had another x plus 6 on the bottom, then we could talk. But that's not going to be something we can break up. Problem 10. I'm going to take 7 out of the top. It has a GCF. I have a 7d on the bottom. The 7's cancel. I'm left with d plus 2 over d. Once again, look at, they're teasing you. They want you to cancel the d's out, but there isn't a d on top. There's a d plus 2 on the top, and I can't break it apart. I can only get rid of holes. I can't take little pieces here and there and kind of chip them away. All right, on the bottom, the top is difference of 2 squares. The square root of x squared, the square root of 1, throw a plus minus in there. The bottom has a GCF of 5. I take it out. Now, you would say I can't cancel anything out, but if you have an entire term that's all the same, you can get rid of it. So the x minus 1's go. You're left with x plus 1 over 5. We can box that up. These are all factoring techniques from chapter 11. We reviewed them in chapter 13, and now we see them again in chapter 14. We're going to modify this assignment. If you want to work on some of them at home, work on evens only. I may cut that down even more, though, because that's still a pretty long assignment. I look forward to seeing you tomorrow. Have a great evening. Take care.